Yes, in this lecture, we will discuss load combinations, load patterns, and load combinations. See, in case of loads, there are mainly two types, or loads are categorized into two. So, first one will be gravity loads, and second one is lateral loads. Again, gravity load include dead and live load. So again, this gravity load includes dead load and live load, whereas lateral load include wind load and seismic loads. So seismic loads are nothing but earthquake loads. So in our course, we are concentrating only on gravity loads because our aim is to design a residential building subjected to gravity loads. So we will be discussing only about live load and dead load. So first we shall see dead loads. So load that is fixed in magnitude and position is called the dead load. So dead loads are fixed in magnitude and position. So examples are weight of slab, weight of slab, weight of beam, weight of wall, weight of columns, partition walls, false ceilings, weight of false ceilings, cladding, claddings, and brick fillings, and plaster, finishes. So all are categorized in dead loads. So you please remember, dead weights of different materials are provided in code IS 875 1987 part 1. So in this code, dead weights of different materials are provided. So if you open the code, see here. So IS 875 part 1. So part 1, which is used for dead loads, unit weight of building materials and stored materials. So in this code, dead weights of different materials are provided. Okay. So next, we shall discuss about self weight. See here. So self weight of slab, beam, column is automatically calculated by ETABS itself based on the size. So you please remember this: self weight of slab, beam, column is automatically calculated by ETABS itself based on the size. So based on the size. Okay. So next, for beams and columns, the correct way of calculating the self weight is kilonewton per meter. So this is the correct way of calculating the self weight for beams and columns. So this is for beams and columns, because if you assume a size of beam or column as 200 into 450 mm, okay, you know the density of RCC, it is 25 kilonewton per meter cube, or unit weight of RCC is 25 kilonewton per meter cube. So here self weight, it is calculated as width multiplied by depth and multiplied by density of concrete. So here it is, width of the section is 200 mm, so which will be 0.2 meter, multiplied by depth of the section, it is 0.45 meter, multiplied by density of concrete, it is 25 kilonewton per meter cube. So if you simplify this, so 0.2 multiplied by 0.45 multiplied by 25, so it will be 2.25. So self weight of this column, or it may be a beam, so it is 2.25. so what is the unit? Kilonewton per meter. So here the remaining is kilonewton per meter. So for beams and columns, the correct way of calculating the self weight is kilonewton per meter. So for slabs, if you assume slab thickness is 125 mm. 125 mm. So in this case, self weight of slab, it is calculated as slab thickness multiplied by density of RCC. So here slab thickness is 125 mm. So it will be 0.125 meter. Again multiplied by density 25 kilonewton per meter cube. So here meter get cancelled. Okay. So remaining will be 0.125 multiplied by 25. So it is 3.125. So here self weight of slab is 3.125. What is the remaining unit? Kilonewton per meter square. So this is self weight of beam or column, whereas this is self weight of slab. For slabs, correct way of calculating the self weight is kilonewton per meter square. For beams it is kilonewton per meter. Okay. Next, we shall see how to calculate floor finish load. So assume total floor finish thickness is around 75 mm. So here if you take a cross section, so total thickness of the floor finish, it is 75 millimeter. So in this tile thickness plus adhesive, so which is the glue used to hold the tiles, adhesive. So it will be thickness of tile 10 plus adhesive 3, so it will be 13 millimeter. Okay. So floor finish thickness, so it will be 75 minus 13, so it is 62 millimeter. So total floor finish thickness is 75 mm. So out of which first you place a cement mortar. So this will be your cement mortar. So this will be your filled with cement mortar. So this layer it is cement mortar. So this is this layer. Here you have tile plus adhesive. So this layer it is your thickness of tile plus adhesive. See here, total floor finish it is 75. So out of 75, so this will be 62 and this will be 13. So if you add these two, you will get total thickness as 75. So 62 is mortar, thickness of mortar. So this 13 mm is tile plus adhesive. Okay. So you know the density of cement mortar. Density of cement mortar. So which is 20 kilonewton per meter cube. Okay. So now let me calculate the load. So first we shall calculate the weight of mortar, cement mortar. So that is 0.062 meter. So this millimeter is converted to meter multiplied by density. Sorry, density here it is 20. Density of cement mortar is 20. So it will be around 0.062 multiplied by 20. So it will be around 1.24 kilonewton per meter square. So this is weight of mortar, weight of cement mortar. So what is the weight of tile? What is the weight of tile plus adhesive? See here. So assume I am using 10 mm thick glazed tile. Assume I will be using 10 mm thick glazed tile and plus adhesive. So this will be, weight of this will be 0.246 kilonewton per meter square. Again this will be provided in IS 4, not IS 456, IS 875 part 1. You have the dead weights for different materials. If you are using 20 mm thick granite floor tiles, then there will be a different weight. Okay. So weight of this tile plus adhesive. Remember, this 0.246 is for 10 mm thick glazed tile. Okay. So weight of tile, it is 0.246 kilonewton per meter square. So if you add this 1.24 plus 0.246, so which will be around 1.486. So I will round off this value to 1.5 kilonewton per meter square. So this will be the floor finish load. So next we shall see how to calculate weight of main wall. Weight of main wall, self weight of main wall. Assume your floor to floor height is 3 meter. Okay. So This floor to floor height, it is 3 meter. So this is your ground floor and this is your first floor. So below the ground floor you have a plinth beams and these are your first floor beams. Okay. So this much area. So this much area is covered with your brick wall. This area, it is covered with your brick wall. So this is your brick wall. So floor to floor height is 3 meter. Then what is the wall height here? Assume this beam thickness is, beam depth. The depth of the beam is 450 mm. It is my assumption. In actual case, it may be 600 or it may be 300. So here I am assuming it as 450 mm depth of the beam. So then what is the wall height? So wall height will be floor to floor height 3 meter minus depth of beam. So it is depth of beam is 0.45 meter. So wall height is calculated as floor to floor height minus your depth of beam. So it will be 3 minus 0.45. So it is 2.55 meter. So this is the height of wall. So this length is 2.55 meter. So this wall is, if it is made up of brick, if it is a brick wall, then unit weight of brick it is 20 kilonewton per meter cube. Assume wall thickness is 0.23 meters. It is a 9-inch main wall. So how to calculate the wall load here? So here wall load, weight of main wall load, it is calculated as height of the wall multiplied by wall thickness multiplied by unit weight of brick or density of brick. So here height of the wall is 2.55 meter, wall thickness it is 0.23 meter, density of brick it is 20 kilonewton per meter cube. So here wall load comes out to be so 2.55 multiplied by 0.23 multiplied by 20. So 11.73 kilonewton per meter. So this is the weight of main wall, or you can round off this value to 11.75 kilonewton per meter. 11.75 kilonewton per meter. So this is the weight of main wall. Then how to calculate the weight of partition wall? How to calculate the weight of partition wall. What is the difference between main wall and partition wall? There will be difference in only thickness. So main wall will have a thickness of 9 inch. So whereas your partition will have a thickness of 6 inch, or sometimes it is 4.5 inch. So either it may be 0.15 meter or 0.125 meter. Okay. So weight of partition wall, it is calculated in the same way, but there will be a change in thickness only. So while calculating the partition wall, instead of 0.23, either you need to use 0.15 or either you need to use 0.125 meter based on the thickness of partition wall. Okay. Let me calculate the partition wall for same data. So next, weight of partition wall we will calculate with the same data. So which will be equal to first height of wall multiplied by wall thickness again multiplied by density of brick. So here height of wall, it is 2.55 meter. Wall thickness, assume it is 6 inch wall, 0.15 meter. Thickness, it is 20 kilonewton per meter cube. So 2.55 multiplied by 0.15 multiplied by 20. So which will be around 7.65 kilonewton per meter. So this is the weight of partition wall. Next we shall see weight of parapet wall. So it is calculated as same formula. Height of wall multiplied by wall thickness again multiplied by density of brick. So remember here, height of parapet wall is around 1.2 meter. Height of thickness of parapet wall, it is 0.2 meter. So density, if it is made up of brick, then it will be 20 kilonewton per meter cube. So which will be around 1.2 multiplied by 0.2 multiplied by 20. So it is 4.8 kilonewton per meter. So you can round off this to higher value. You can directly take it as 5 kilonewton per meter. So your parapet walls will be only on your roof floor. That is only on periphery. Okay. So next we shall see how to calculate sunk slab load. So we shall see how to calculate the sunk slab load. So where you provide the sunk slab? So you provide the sunk slab only for toilet area or bathroom areas. So first you should know the depth of sunk. Depth of sunk. See here. So this is the cross section. So this will be your normal slab. So this is your sunk slab. So this will be your sunk slab. So this is your normal slab. So here, see here, normal slab and sunk slab. So they are at two different levels. So once you cast the sunk slab, later it is filled with brickbat or cinder. Then you can take out the toilet pipes here. So you can take out the toilet pipes here. Okay. You can fix the water closets at a desired location. Then after which again you have tiles. Okay. So we need to calculate this sunk load and this floor finish. So whenever there is a sunk slab, you need to assign two loads. One is your sunk load plus your floor finish in case of dead load. Again there will be a live load. Okay. So first you should know the depth of sunk. So usually it is around 0.3 meter. So depth of sunk, it is 0.3 meter. Then you should know filling material. Assume at the site they will use cinder. So this sunk slab is filled with the cinder. So density of cinder, it is 8 kilonewton per meter cube. Again this value it is extracted from IS code, IS 875. So sunk load it is calculated as, see here, 0.3 meter depth of sunk multiplied by density 8 kilonewton per meter cube. So which will be around 0.3 multiplied by 8, 2.4. So which will be around 2.4 kilonewton per meter square. If it is filled with cinder, what if same sunk slab it is filled with the brickbat coba? So here density of brick is 20 kilonewton per meter cube. Density of brick it is 20 kilonewton per meter cube. So in this case it will be depth of sunk 0.3 multiplied by density of brick, it is 20 kilonewton per meter cube. So which will be around 0.3 multiplied by 20. So which will be around 6 kilonewton per meter square. 6 kilonewton per meter square. If we use cinder as filling material, then you will get a sunk load as 2.4. For the same sunk, if you fill with brick, if you use brick as your filling material, then the sunk load will be 6 kilonewton per meter square. First, you should ask site layperson what material he is using. Based on that, you have to arrive the sunk load. Okay. So next, waterproofing load. Waterproofing load. You please remember, waterproofing load will be taken only on roof slab. So this will be taken only on roof slab. So generally we consider waterproofing load as 2.5 to 3 kilonewton per meter square. 2.5 to 3 kilonewton per meter square. Okay. Next, we shall see staircase loads. So staircase loads. So here in staircase, again you have dead load and live load. So your dead load includes self weight of waste slab. It will be automatically calculated by ETABS software based on the size. If you modeled your stair weight slab, and this dead load include floor finish plus railings plus weight of riser and thread. Okay. So for staircase, dead load, it is around 2.5 to 3 kilonewton per meter square. So it is dead load. So for live load, it is 3 kilonewton per meter square. If it is staircase, it is located in a residential building. For residential buildings. For public buildings, it is 5 kilonewton per meter square. So this is for public buildings. Okay. Next we shall see live load. Live load or imposed load. See here, live load includes items such as occupancy by people. So live load include movement of people, movable equipments, movable equipment, furnitures, any other stored materials. Okay, so this will comes under live load. So live loads are different for different types of buildings such as domestic, office and warehouse. So different buildings will have different live loads based on the occupancy. So for live loads, for the complete guidance of imposed loads on floors due to use and occupancy, you can refer IS 875 1987 part 2. Again it is in table 1 and in page number 7. So this is for live load on floors. So you may refer IS 875 1987 again part 2 clause 4 I think it is also table 1 page number 13. So this is again for live loads, roofs. So let me open the code and check it. So IS 875 part 2. See here, the title will be imposed loads. So if you refer table 1, imposed floor loads for different occupancies if it is a residential building. So in our project we are dealing with designing with the residential building. So for all rooms and kitchens, live load it is taken as 2. For toilet and bathrooms it is 2. Corridor, passage, staircase it is 3. Balconies it is 3 kilonewton per meter square. Okay, so live loads are different for different types of buildings. See here, first one is residential building, so second it is hotel, hostel, boarding houses, etc. So this is for floors. Again on the roof, see here, you please make a correction here. This is not table 1, this is table 2. So table 1 is for floors, table 2 is for roofs. See here, if your table 2 imposed loads on various types of roofs, if access provided, then live load will be 1.5 kilonewton per meter square. If access not provided except for maintenance, then it is 0.75 kilonewton per meter square. So if on the roof, if access provided, so then the live load will be 1.5 kilonewton per meter square. If no access provided, so then live load on roof will be half of that, 0.75 kilonewton per meter square. Okay. So this is all about gravity loads. So we shall see how to assign the loads, how to define load pattern and load combination in ETABS. In the same lecture, we shall see how to assign these loads in ETABS. So first open your ETABS software. Yes, once you open your ETABS, so open any of your ETABS model. Okay. So this is my ETABS model. Still it is loading. Okay. So this is my ETABS file. So first you go to any floor, roof or first floor or second floor. You just create another new window. So on the one side, left side you have plan, on the other side you have 3D. Okay. So first you need to define load patterns here. The first and foremost thing is you need to define load patterns in ETABS. See here, for which again you are designing a structure only for gravity loads. So your gravity load includes dead and live, dead load and live load. Okay. So because of which you have only two load patterns. So one is dead load and another one is live load. So you have two load patterns. So these are your load patterns. One is dead load and another one is live load. Okay. So first you go to First you go to define. In define, load patterns. You click on load patterns. I think by default in ETABS software you have dead and live. So by default there will be two load patterns, dead and live. Okay. See here. So here for dead self-weight multiplier it should be 1. For live the self-weight multiplier it should be 0. So don't put self-weight multiplier as 1 other than dead load. What if you put self-weight multiplier as 1 in live load also? So see here, if you put self-weight multiplier as 1 with the live, in dead also it will calculate the self-weight, and in live also it will calculate self-weight. The self-weight value will be get duplicated. So self-weight multiplier it should be only 1 in case of dead. In case of live it is 0. So don't put again 1 here. If you put 1 here, the dead load, the self-weight will be duplicated. Okay. You please remember another thing. Self-weight means own weight of slab, beams and columns. So whenever I say self-weight means it is own weight of slabs, beams and columns. It will be automatically calculated by ETABS software itself based on the sizes. No need to calculate the self-weight here. In ETABS software, the self-weight will be automatically calculated. Okay. Once you create a load pattern, one is dead, another one is live. You just click on OK. Okay. So next, first we shall see how to assign frame loads. First we shall see how to assign frame loads. Okay. See here. If you want to assign wall load for these 3 beams, so for beam number 32, beam number 37 and beam number 42, so I need to assign frame loads, that is wall load. Either it may be a partition or main wall or parapet wall. The procedure will remains the same. So first you select these 3 beams, you go to assign frame loads. In frame loads you select distributed. See here. In load pattern you have dead. So your wall load, main wall load, partition wall load and parapet wall load comes under dead load. Okay. So here direction of load application, it should be always gravity. Gravity means which is along downward direction. Okay. Here uniform load, I think it will be around 11.75 or you make it as 10. You make this as 10. I will take this later. One is add to existing loads, replace existing loads, delete existing load. I'll take this at the later stages. So first uniform load, you gave it as 10. Any load, it is as per your calculation. So you go to apply, OK. See here, the load, it is assigned, but it is not visible. You go to set display options, you remove the unique names, apply, OK. See here, the load is assigned as 10 kilonewton per meter. So in the 3D view, you just activate by clicking on this 3D view. You go to display, load, assign, frame, dead, apply, OK. See here, so this is your 10 dead load, it is assigned. It is earlier load, don't confuse this with earlier. I assigned 5 for this beam also. Okay, again you select these three beams, go to assign, frame loads, distributed. You click on this option, delete existing load. Whatever the load that is assigned on those beams, it will be get deleted. See here, you select delete existing loads, apply, OK. Again you just activate this window, you go to display, load, assign, frame, apply. See here, on these three beams, load gets deleted. You select this beam, you just click mouse right button on loads. Oh, okay, I think it is in live load also. Earlier I assigned 5, I delete everything. You select these beams, you go to assign, frame load, distributed. In case of live also, you delete it. You select this beam, assign, frame load, distributed. See here, I delete all the loads. See here, if you just click on this beam and you click mouse right button, in case of loads, see here, it is showing none. None means no load is assigned. It is showing none. So once you select these three beams, see here, in the status bar, it is showing 3 frames selected, which means you selected 3 beams. You go to assign, frame load, distributed. You just gave any value, 10, apply, OK. So see here, once you select beam, click mouse right button. Now see here, on the dead load, you assigned 10 kilonewton per meter. You just activate this 3D view, you go to display, load, assign, frame. You select load pattern as dead, apply, OK. See here, again you select the 3 beams, you select 3 beams, you go to assign, frame loads, distributed. You select this option, add to existing load, and you use uniform load as 5. What will happen? Initially you have 10 kilonewton per meter. Now you are assigning 10 kilonewton per meter. What is your option? Add to existing load. This is your existing load. It was already existing on the beam. Existing load is 10 kilonewton per meter. This is your new load. This is your new load, 5 kilonewton per meter. Because you selected the option add to existing load, what will happen? So it will happen 10 plus 5, 15 kilonewton per meter. See here, you select this option, add to existing loads, you click on apply. Okay, see here, now the change is 5 plus 10, 15 kilonewton per meter. You select this beam and you click mouse right buttons here. First you assigned 10, next you assigned 5, so totally it is 15. To see the 15, you just activate this 3D view. You just click on this view, you go to display, load assign, frame, you go to load pattern dead, apply. Okay, see here, now it is 15. Now it is 15. How to delete these loads? You select all the 3 beams, you go to assign, frame loads, distributed, you click on this option, delete existing loads. Here the load pattern, you should select correct load pattern. You assign the load in dead load. While deleting also you should select dead. Instead of dead, if you select live means it will not delete anything, because your load is in dead load. You are telling the software that your load pattern is live load and you delete the load in live load pattern. Okay, so you select dead here, apply. Okay, you just click on this any beam. See here, no load. So how to activate here? You just click on this 3D view. You first activate this window. How to activate this 3D window? You use mouse click. You go to display, load assign, frames, dead. See here, no load is assigned. You select this beam, you right click, loads, in case it is showing none. So this is the procedure to assign the frame loads. You should be careful, you should be very careful in case of these 3 options. One is add to existing loads, replace existing loads, delete existing loads. I will select this one, replace existing loads. See here, first I will assign 10, assign frame loads, distributed. First I will assign 10. I will close this 3D view. So here I have a load of 10 kilonewton per meter. So you select these 3 beams, go to assign, frame load, distributed. See here, what will happen if I select replace existing load? See here, my original existing load is 10, my new load it is 5. So what is the command option? I have selected replace existing loads. See here, 10 kilonewton per meter is existing load. What is the new load? It is 5 kilonewton per meter. This is your new load. Your option is replace existing load. What the software will do? It will automatically delete this existing load and will assign this new load. See here, you just click on this, apply. Okay, see here, it is automatically changed to 5. See here, in case of loads you are having only 5 kilonewton per meter. So this 10 it is automatically deleted because your option was replace existing loads. Okay, how to delete? You select all the three beams, assign, shell, frame loads, distributed. You select this, delete existing load, play. Okay. In plan view also you can assign the frame loads, or in 3D view also you can assign the loads. See here, in 3D view you select these three beams. Here in status bar you please check how many frames or beams have selected. You go to assign, frame loads, distributed. You should be very careful about the load pattern, on what load pattern you are assigning. Okay, so you give 25 here, apply. Okay, see here. Okay, so this is how you can assign frame loads. Next we shall see how to assign shell loads. So you go to display, click on undeformed shape, you go to plan. Okay, so next we shall see how to assign shell loads. So shell means it is slab load. The correct way of defining the shell load is kilonewton per meter square. In case of frames means it is beams and columns. The correct way of defining self weight for beams and columns is kilonewton per meter. So this is already we discussed in our theory part. Okay, so next we shall see how to assign shell loads or slab loads. You select these three slabs. See here, 3 shells and 12 edges selected. For each slab there are 4 edges. If you select 3 slabs, then there will be 12 edges. You go to assign shell loads, you click on this uniform, same, this is same options. Load pattern name, again you have 2 load pattern, dead and live. Again direction, it should be always gravity. This option is same as frame loads. Add to existing loads, replace existing loads, delete existing loads. I will choose 2. Just click apply. Okay, here it is overlapped. Section name and your load values are overlapped. To remove this, go to set display options. In set display options, object assignment, you, in case of shell assignment, you uncheck this, apply. Okay, see here, on these 3 slabs you have assigned a load of 2 kilonewton per meter square. That is, load pattern is dead load. How to delete these loads? How to delete these loads? You select 3 slabs, you go to assign shell loads, uniform, you select this one. Your load pattern should be correct. You select load pattern as dead, you select the options, delete existing loads, apply. Okay, see here, the load gets deleted. How to check this? You click this slab and mouse right click. In case of loads, it is showing no loads. So I will use live load and dead load. So I select all the 3 slabs, go to assign shell load, uniform. In dead load also I will assign 2. Again I will select same 3 slab. In live load also I will assign 1.5. See here, if you select this slab, you click mouse right button. See here, on the dead load pattern, I have 2 kilonewton per meter square, and on the live load pattern, I have 1.5 kilonewton per meter square. So how to view these? You go to display undeformed shape. So how to view this? Either you can select this slab, mouse right click, and you can check it here. What is the load assigned? Or other way is you go to display load assign. In this case, you select shell. See here, load pattern, it is dead. I want to see what are the load assigned on this load pattern. Dead, gravity, you click OK. See here, on the dead load, you have 2 kilonewton per meter square. What if I select live load here? If you select live, apply, OK, see here, on the live load it is showing 1.5, because for this slabs I have assigned a dead load as 2 kilonewton per meter square and live load as 1.5 kilonewton per meter square. Okay, so I have now, see here, now I have a live load of 1.5 kilonewton per meter square. See here, you assume like this, I have to assign 3 kilonewton per meter square. By mistakenly I have assigned 1.5. So to match this 1.23, I need to assign another 1.5 kilonewton per meter square. See here, you select these three slabs, you go to assign shell loads, uniform, you select live load 1.5, direction, gravity. What if you select add to existing load? It will become 3. See here, apply, OK. See, now it is changed to 3. So my existing load was 3 kilonewton per meter square. My new load was 1.5 kilonewton per meter square. This is my new load. While assigning the load, I have selected the option called add to existing load. Add to existing load. So sorry, this is, earlier it was 1.5 existing load, it was 1.5 kilonewton per meter square. So as my option is add to existing load, so it will be 1.5 existing load plus 1.5 new load. So it became 3 kilonewton per meter square. So now it is 3 kilonewton per meter square live load. So out of 3 kilonewton per meter square, I need to deduct 2. Which means I need to assign only 1 kilonewton per meter square. So you select this particular slab, go to assign shell load, you select uniform. In live load, you go to replace existing load. Replace existing load. See here, if you select this as 2, what will happen? 3 is removed and the new load will be 2. You just click apply. Okay, see here, this 3 is vanished and the new load is 2 kilonewton per meter square. On the plan view also, you can assign the shell loads. On 3D view also, you can assign the loads. See here, on the 3D view, you select the particular slab on any floor, you go to assign shell load, uniform, you select the load pattern accordingly. You should be aware of these three options. Apply. Okay, see here, on all the slabs I have assigned the load of 2 kilonewton per meter square. So this is about your frame loads and shell loads. Now we shall see how to define load combinations. We shall see how to define load combinations. So in case of limit state method, you have two limit states. One is limit state of serviceability, another one is limit state of collapse. So in case of limit state of serviceability, your load combinations are unfactored load combination. In case of limit state of collapse, your load combinations are factored load combination. So if you are dealing only with gravity loads, so your load combinations are in case of limit state of serviceability. So first one will be dead load, first case. Second case will be dead load plus live load. Okay. In case of limit state of collapse, first load case will be 1.5 times dead load DL. Second case will be 1.5 times DL plus 1.5 times LL. Okay. So out of these combinations, in these two, which one is the critical? So this is the critical. For limit state of serviceability, critical combination is dead load plus live load. For limit state of collapse, critical load combination is this one, 1.5 dead load plus 1.5 live load. Okay. Now I will show you how to define your load combinations in ETABS. You go to define load combinations. You select this load combinations. See here. Go to add new combo. What is your first combination? In case of limit state of serviceability, it is DL. Here combination type, it should be linear add only. Here you just first you delete this one. How to add load patterns? Here you go to add. See here. Here you have dead, live, model, wind. You select only dead. So in case of limit state of serviceability, scale factor it is 1. I told you in the beginning. So in case of limit state of serviceability, first load combination is DL. So scale factor is 1. You click on OK. See here. Here combination is DL. Again you click on this add a new combination. What is our second combination? So it is DL plus LL with scale factor 1. So in combination name you write DL plus LL. Here combination type, it should be linear add only. Okay, you just delete. Again you click add. See here, dead load is come up with, you change the scale factor, it is 1.5. Next you click on this add. Here you select live for which scale factor is 1. Sorry. So here the combination is dead plus live. So scale factor it is 1 and 1. For live load also it is 1. For dead load also it is 1. Okay. You just click OK. See here. These two are your limit state of serviceability. So these two are your limit state of serviceability load combinations. In case of limit state of collapse, what are your load combination? First load combination is 1.5 times DL and your second combination is 1.5 DL plus 1.5 times LL, live load. So you click add new combination. Here it is 1.5 DL, dead load. Here the combination type, it should be always linear add while creating the load combination. So you select dead. Here the scale factor is 1.5. You click on OK. See here 1.5 DL. Again you go to add new combo. Your second limit state of collapse combination is 1.5 DL plus 1.5 LL. Combination type linear add. So dead load, you change the scale factor to 1.5. Again you add live, scale factor 1.5. So it is 1.5 DL plus 1.5 LL. Okay. See here. You have 4 combinations. Out of 4, 2 are limit state of serviceability, 2 are limit state of collapse. If you want to edit, you can click on any combination, you go to modify. You can change the scale factor, you can change the load name also. Okay. How to delete? If you don't want any combination, means how to delete, you just click on those combination, you click here delete combo. You click on this 1.5 DL and you press delete combo. Okay. So this is how you can define your load combinations. Okay. So next part will be meshing. So next part it will be meshing. So as your ETABS is finite element method software, it uses the finite element method to solve any problem. So in finite element method you need meshing. You need to mesh your objects. So how to assign the mesh? So you go to analyze, you click here automatic mesh settings for floors, in which you select a rectangular mesh. So approximate maximum mesh size, for which for slabs it is 0.3 to 0.5, 0.3 to 0.5. You can use those mesh size. So I will use 0.3. You just click OK. You save your model. So it is not visible on your physical model. To view the meshing, you go to analyze, you click on this run analysis. You run analysis, analyze your model. It will take some time based on your system speed and your graphic card configuration. See here, now the slabs are meshed. So these slabs are meshed into 0.3 meter by 0.3 meter size. You used rectangular mesh. So this is the preferred size for your slabs. If you want, you can use triangular and quadrilateral mesh shapes also. So for slabs, ideal it is use a rectangular mesh. See here, from here to here it is span is 5 meter, which means 5000 millimeter. My mesh size is 0.3. My mesh size is 0.3, which is 300 millimeter. So how many elements I have? So you calculate it as 5000 divided by 300. So it will be 16.6 elements. So you should have 16.6 elements. So you can count to verify. See here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and this is 17. So totally you have 17 elements. So once, if you analyze your model, how to bring it back? So you just go to display undeformed shape, and here there is a lock or unlock model. Once you analyze your model, it will automatically lock your model. So to unlock your model, you just click on this option. So last is check model option. See here, you go to analyze, check model, you click on, you check all these in joint checks, frame checks, shell. You leave these two as empty, don't select these two, fix. You can use the length tolerance. Here you can use the length tolerance as 20 to 25 millimeter. 20 to 25 millimeter. So I will use 25 millimeter. I will use 25 millimeter. You just click on OK. See, model has been checked. No warning messages were generated. Okay. Why I have selected the tolerance factor as 25 mm? Why I have chosen this value only? Because see here you have a joint If I give a tolerance factor of 25 mm, tolerance factor as 25 mm, it will check for any duplicate node on this adjacent to this node at a distance of 25 mm. Similarly, at this joint also, this will take a arbitrary area of 25 mm and it will check for any duplicate nodes or any overlaps. Okay, so length tolerance factor should be around 20 to 25 mm. What if you select length tolerance factor as 4000 mm? What if you select length tolerance factor as 4000 mm? See here. Here you have a joint. If you give tolerance factor as 4000, the area becomes bigger. This adjacent node, the ETABS software will treat this node as a duplicate node, even though if it is correct, because you have gave the length tolerance factor as 4000 mm. So ETABS will treat this node also duplicate node and it will treat it as warning or error. See here, I will show this. You go to analyze, check model. I will change the length factor, tolerance factor as 4000. Okay. See here, now it is showing duplicates nodes are created and you have overlaps, etc. It is showing. So your length tolerance factor should be around 20 to 25 mm. Don't go beyond this. So go to analyze, check model. So 25. Okay. So finally you should get this message. Model has been checked, no warning messages were generated. Then your modeling is correct. You have no errors or any warning messages. Okay. Once you complete the modeling, so first step is modeling. So next, once you complete, next will be analysis. So for which it is simple. You just click on this analyze, run analysis. Okay, I may getting error in performing run analysis. If you click here, it will take you to run analysis. You just click on this option, go to analyze, run analysis. It will analyze. So once you complete this analysis procedure, so after running our analysis, what are we expected to do? We will be now going ahead with design iterations to finalize the optimum sizes. So once if you complete the analysis, we will go for slab design, next followed by beam, next followed by column, next followed by your footings. Okay, so in the next class, we will take up this session. We will take up deflection check for deflection check for slabs. We will take up this part in the next lecture. You practice these commands. Okay, in the next lecture we will be discussing about slab deflection check.